Yeah, this is Richard Daigle from the Green Industry News, and I'm at Griswold in Irvine, and I have Rocky, the National Sales Manager for all the irrigation division here, and he's going to be introducing you and talking to you about Griswold today.
Hi, this is Rocky Marciano. I'm the Irrigation Sales Manager for Griswold Controls. And today we are going to be talking a little bit about the products, both the DW series valves and the 2000 series valves. A little bit about me: I've been with Griswold 8.5 years, and like I said, I'm the Irrigation Sales Manager and on a global basis, so I cover pretty much everything in the whole world. Concentrate a lot in the U.S. Market because that's where a majority of our sales are currently. Griswold, we just celebrated 50 years in 2010, so we've been around for a while. Okay, what we're going to do is we're going to start with Model 2000. This happens to be a 3-inch, and I've got it pointed towards the camera so you can see the direction of flow. And obviously this is very critical when you install the valve, but a lot of times I'll get calls, and one of the questions I ask the contractors or whoever did the installation, if it's a municipality, is the valve installed properly? So make sure that you look at this direction of flow, hopefully before you install the valve. So I've got the bolts off. One of the things that I do is I will loosen up the flow control handle and get the pressure off the spring inside. So because a lot of times when you're trying to do this in the field, we might have some gurgling coming up, but obviously you want to shut the water off before you start this process. So we open that up, and then we'll unscrew our bolts off of our bonnet, and I always keep my hand on top of the bonnet so it doesn't come up and smack me in the face. And when you're in a valve box, that could happen. So what I'll do is I'll take the bonnet off. We also call it a cover. Then your spring for your diaphragm. This is very important. Make sure that you pull the metering pin out first before you lift up the diaphragm. A lot of times I'll get on a job site and I've been called that the valve won't work, and I've asked the contractor, have you taken the valve apart? And they say yes. So when we take the bonnet off, the metering pin is gone. If you take the diaphragm out first and leave the metering pin in, it's going to fall inside the valve, and now you're going to have issues. So this is real important. And on the metering pin, when you put it back in again, make sure that the flat part of the metering pin is down first and the pointed part is sticking up. It can only go in one way. If you reverse this, you're going to have problems with the valve. The valve may not open and it may not shut. Okay, so you've taken the metering pin out. Then this first gasket, we call this a high pressure gasket, and this sits on the outside of the diaphragm assembly, and it sits there for more sealing of the valve, because again, some of these valves are rated for 300 psi. Now this happens to be just a standard model number 2000, and you can tell that with the copper solenoid on top, and it's a normally closed valve, which means that when it's not being energized through the solenoid, the diaphragm is in the closed position. Then what you want to do is you want to take out your diaphragm. So when you take the diaphragm out, and our diaphragms for the Model 2000 or for the Series 2000 from 1 inch through 3 inch, they all have the same configurations, just different sizes for the different components. When you're taking apart the diaphragm for the Model 2000 from 1 inch through 3 inch, you would unscrew your pin bearing. You would take out your retainer, and then you just saw the O-ring pop out. Well, if it's been in the ground for a while, this O-ring is going to be a little smashed. So make sure you take the O-ring out, and then take your diaphragm out. And so if you don't have to replace your seat disc, then when you're putting this back together again, do not put the O-ring like this. Your valve will not work. The O-ring has to go on top of the diaphragm. And that's the way it's going to work. So you can hand tighten this. We don't have any torque requirements on this. Hand tighten is going to be good. Okay. Like I said, this is our pin bearing, and this is the one that changed. We've made this change roughly 8.5 years ago, and then we have now this metal insert inside the pin bearing. So the old style pin bearings were all brass. They didn't have the metal insert in. So because of our metering pin being serrated, that the valve opening and closing, this would go up and down. So we were wearing out the inside of the pin bearing. And by doing that, it would get egg-shaped. So when you're out in the field, make sure if you've got an old style pin bearing, I would just change it. But if you really want to make sure that it's egg-shaped, just take your metering pin and put it in the center and just move it around. And you'll see that movement, and you'll see the egg-shaped. Okay? So this is now what our pin bearings look like. Okay. Also inside the valve. Now what I'm showing you is our epoxy coated feature. This is an option. And the color is blue, it's not green, and the old style epoxy was green, and that you can see here to my left. We epoxy coat the inside of the body as well as the outside of the body. The only thing we don't epoxy coat is the threads themselves. Now, this is very critical if you have reclaimed water or if you have other than potable water. What will happen is if you're in an area that you winterize the valve, so you don't have any water through the valve, what will happen is if this is just a standard cast iron body, and it's going to be, we actually paint the bodies, and it's just a paint, and it's a kind of a rust color. Okay, so what'll happen is, without any water in the valve, you'll get some on this ridge where part of the diaphragm sits. You're going to get growth of rust, and this happens because of iron normally. So you could have iron in your soil, you could have iron in your water. It really depends, and a lot of reclaimed water has iron in it. So that could be an issue. So if you don't exercise your valve or have a winter type program to where you're turning the valve on and off maybe once or twice, maybe 3 times a week, just to open it and close it, you're going to get this attachment right here in this part of the diaphragm against this ridge in the valve. Okay, so that's why the epoxy coating, I always recommend it if you're going into reclaimed water especially, or other than potable water. Spend the extra money and do the epoxy coating. The valve will double in its life. Now if you, one of the things with epoxy though, if you scratch the epoxy and you gouge it out, what's going to happen is you're going to get a rust buildup in that open area. So be prepared for that. If it's on the outside, it's really not going to hurt anything. But inside this area here, you want to be more careful. Also, our seat assembly on our 2000 series valves, from 1 inch, 1.25 inches, 1.5 inches, 2 inch, 2.5, and 3 inch, we have removable seats. And I don't know if a lot of you really realize that, but these seats can be replaced. Now we also actually have tools that we sell, and these are the seat tools themselves. And there's 3 different sizes because we have the different sizes of the bodies. So these can be purchased through your local distributor. They call us for a part number, and we'll give them a price. We actually don't keep these in stock. We'll make them up as we get the orders. Okay, so it's a lot easier putting this in and taking the seat out. Now also on the seat itself, you have this guide tube. Well, inside the guide tube is a guide spring and a cap. And the reason we do that is because our metering pin is floating. It's not stationary in the valve. That's why we want you to pull it out before you take the diaphragm out. You always have to check inside this guide tube to make sure that the spring and cap is in there. And when you're in a valve box, it's a little bit more difficult. That's why I just take the metering pin itself and I put it in the center of the guide tube and I push it up and down, and I make sure that you've got the spring is actually got some tension in it, so the metering pin will move up and down. And also on our DWS, now I happen to have just a body open right now. Our seat is not removable, it's part of the casting. So here we don't have removable seats on our DW series, which is our all brass valve. Now this comes in 3/4, 1 inch, 1.25 inches, 1.5 inches, and 2 inch. And this particular size, this happens to be a 2-inch body. So our lane lengths are quite a bit smaller than our competition. So you might want to look at this valve too if you've never used it before. It's a great tool out in the field. Plus this has the same features. It's a slow closing valve, and it's got the continuously self-cleaning valve. Early on in my presentation, I talked about the fact that we have the continuously self-cleaning valve. And as I said, that water comes up through the center of our diaphragm assembly. And when it hits the guide tube, that water wraps around the guide tube and pushes up through the center of the valve. And then we're actually pushing water through the center of our diaphragm assembly, up through our diaphragm assembly, hitting our metering pin. And when we do that, this metering pin looks like a screw, like I said. And as that water's being pushed up, that water will actually start swirling like a tortuous path emitter and start swirling around. And as it's doing that, we're creating a turbulence on top of the diaphragm assembly. And as we do that, we're cleaning on top, but more importantly, we're cleaning inside the bonnet area. And this is where your plugging comes from. We have valves coming out of the Mississippi River. We have valves in Hawaii where they have what they call brackish water, which is rainwater, salt water, and volcanic silt. And we don't have really a clogging problem like some of our competitors do. So this is a big feature, and I really like to talk about that a lot. Okay, so now what we're going to do is we're going to put the valve back together again. Now the only thing you have to worry about with the Model 2000 and our Model 2030. Now our Model 2030, the only difference is that instead of having a copper can solenoid, we are going to have a black solenoid with 2 red wires on it. This is our low power solenoid. Now we actually used to have a low power solenoid that was like 3 inches long. We do no longer make this, and we haven't for the last, well, since I've been here. So at least I want to say 10 years. This is too costly. So what we've done is we've taken our low power solenoid and reduced it in size and also cost. So it's black with the 2 red wires on it. And your holding current on this particular solenoid is 0.075 amps. So it's extremely low. So if you want to add more valves on a station because of your water window requirements, you can, as long as you have 2 things. You have a lot of pressure in the system to do this, and you also have to have the gallons per minute in the system to run, like maybe 10 solenoids at a time. You have to look at your controller that you're using, make sure that you have enough amps on the transformer to do this. So you can use that. So those are the only two differences between a Model 2000 and a Model 2030. Now, because we're using the Model 2000 and the Model 2030, we have this tube that sits on the downstream side of the valve because we're running water through this tube up to the solenoid area. So when you're reinstalling your diaphragm assembly, you have to make sure that your holes match up and you actually go over that copper tube. And also the same thing goes with your high pressure gasket. Okay? Make sure that your metering pin, your flat part goes down first. Then you would take your cover spring, this is what we call it, take your bonnet assembly, and again remember I had this open all the way so it's a lot easier to reassemble this when you put it down, and start screwing your bonnet together. Now one of the things you're going to see with our valves is we now have a metal tag on each valve from 3/4 inch all the way to 3 inch. And on this metal tag it has the model number of the valve, but it also has what we call an SO number. That SO number is our sales order number. Make sure you put this back in because if I ever am out in the field with you or I'm talking to you on the phone, I'm going to ask you for this, and because I can tell based on the sales order number how old the valve is. Okay, and then once you get the 4 bolts on the valve, you want to tighten them down. We don't have any torque requirements on our valves, so you can do it at hand tight. You don't have to use a torque wrench to tighten it down. And as you tighten it down, make sure that you tighten it down the same way you would tighten down your wheels of your car. So instead of going this way, you always want to go the opposite side. Okay? Okay, so now we've done a diaphragm repair, basically, and we have 2 diaphragm kits. We have one for the Model 2000 from 1 inch through 3 inch, and we have diaphragm repair kits for the 2000 series. Now you notice that they come in a shrink wrap package. Now there's 2 different categories of diaphragm repair kits. You can go either one, but the ones that I'm showing you are the higher, they have more parts to them. You can get a lower priced one. There's only probably not even $10 difference in price. But like for instance on the Model 2000 or on a 2000 series valve, you're going to get your pin bearing. You're also going to get a metering pin. You're going to get your diaphragm. You're going to get your disc. You're also going to get your O-ring that goes on top of your diaphragm. And there's also a smaller O-ring, and that smaller O-ring is actually for the stem assembly on your valve, on your bonnet. Now on the Model 2000, what we do is we actually incorporate a plastic tool. This is the only time you'll see us use plastic, basically. And there's instructions that come with these. And the O-ring, instead of trying to do it with a flat screwdriver, we have the tools. And there's a groove inside the bonnet area. So you'll be able to use the top tool and the bottom tool, and you'll be able to just manipulate that O-ring, get it into the groove and go. The only time you need to change your O-ring is if your stem is weeping or it's leaking water. Okay?
Irvine, California. We're at Griswold Controls. We're going over the DWS valve. Griswold 2230, the 2260, 2000 series. We're going over solenoids. We've got some great education for you guys today. We had a great educational day with Rocky here, and hope you guys learn a lot of stuff from Green Industry News. Thank you.